Hi guys, today we're gonna discuss about projectile motion, and as you can see we're discussing about an oblique projectile. So imagine a man holding a gun, fires the bullet, and the bullet traces this inverted parabola. So let's assume the velocity of the bullet to be u, and I'm gonna break it into its components. I let this angle be theta. So this is going to be u cos theta, this is going to be u sin theta. And one great thing about vectors is that now all the vectors in this direction, or let me put it properly, the effect that this vector causes in this direction would not affect whatever this vector does in this plane. So let's start with your displacement in x. I'm assuming all of you know the Newton's laws of motion. This is the second equation from Newton's laws of motion. Okay, so velocity in x is nothing but u cos theta you must note that there is no acceleration in this x-axis. There's only an acceleration in the upward direction, which is negative g, because the projectile is traveling against gravity. And now let's do our displacement in y. Please note that these two do not affect each other. They are independent of each other. Now the velocity in y, which is u sin theta, acceleration in y, as I said, is negative g. There you have it. Now let me just state the given. Velocity in x is u cos theta. Velocity in y is u sin theta minus gt, because the equation was v is equal to u plus at. Now let's find the time taken to reach this max height. So you must notice that the velocity in y is 0 at this point. There is a velocity in x, but as far as the y plane is concerned, there is no velocity. So we're going to let this equal 0. Rearranging, we get, now this is just the time taken to reach from this point to this point. So logically it would take double the time to reach from this point to this point. So I call that the time of flight. Capital T is equal to 2u sin theta over g.